Hello, and welcome to our lab, our EGR lab for our 1998 Ford Ranger 3.0 liter engine. Today we'll be talking about EGR. Basically, the concept of EGR is to decrease nitrogen oxide. And how that is formed, it's with carbon and carbon dioxide and oxygen. Whenever they exceed 2,500 degrees Fahrenheit, they form an excess of nitrides of oxygen, or NOx. And NOx is what forms smog in the big cities, if you've ever seen that. And basically, we don't want that. And so, to combat this, manufacturers started putting EGR in vehicles. Basically, what EGR does, it's exhaust gas recirculation. And so, we take gas from the exhaust and we put it back into the intake. So you can see which effectively makes the engine smaller, as there's less actual combustion going on in the engine, and effectively decreases temperature inside the combustion chamber and also increases fuel economy, which is great. So time for operation on EGR, it's really only effective on the mid-range on throttle, so probably about 2,000, 4,000 RPMs. That's when we're going to find the best use for it. Whenever we're wide open throttle, we're not worried about fuel efficiency or being fuel efficient, emissions and stuff. We're just trying to produce power. But whenever we are right here at cruising, which is when we most want EGR, that's when we want to be most efficient, and when we want to reduce emissions the most, that's when we open up the EGR to get that exhaust gas in there, lower the temperature in the combustion chamber, and also, EGR is closed on idle too. And that's because, as you'll see later whenever we test these, whenever you put exhaust gas into the engine during idle, it just chokes it out and kills it, because we do need all that pressure and all that size there in the combustion chamber.
Welcome back. We're going to be talking about the specific EGR in this vehicle. So right here is our EGR. It is a diaphragm. So it's just like the picture here, where it has this diaphragm right here. And that is controlled by a vacuum solenoid back here that actuates the amount of vacuum that is allowed to go to the EGR, such as this right here. And it is also it contains a DPFE, which aids in sensing the amount of EGR flow that is actively moving throughout the system. With this test, we'll open the EGR and allow it to flow through at idle and witness the effects of it. In our scan tool here, we got a couple different, we got fuel. Big one is RPM, because I don't have a tach, so nice and Christmassy tach here. So here we go. We're currently at around
Move it off there.
Oh, my bad. 800 RPM. And then when I increase our So when we increase the duty cycle of the EGR, as you can see right here, our current duty cycle is 30%. We increase it to 40. Gets rough. 50. Give a little gas. This is our 2006 Toyota Corolla.
Subscribers better see it.
Maybe I can't talk.
All three of them.
Four.
Four now. Dylan, subscribe.
Currently, we have our VVT solenoid hooked up to our own meter. And we have our testing procedure here. And so right here in bold, it's a 6.9 to 7.9 ohms at roughly 68 degrees Fahrenheit. We are currently sitting at 8.2, but with our PID readout on our multimeter, which we do not have we had to lend it out, but it is roughly 80 degrees in here, so our number is a bit higher, but the temperature is also a bit higher, so that would be understandable. Yeah.
Docking your points if you're putting this in the video.
I couldn't hear you. So here we have our VVT solenoid hooked up to ground on our alternator and has a wire that is able to be placed on the power when ready. And so we are just going to actuate the solenoid. Here's our diagram. And as you can see, it just receives power and ground from the PCM. So we replace the PCM with power and ground from the battery, as shown with this test right here. When it receives, so it's normally grounded, and when it receives power, it will actuate the solenoid. So we're going to click it, and as you can tell, you can hear that.
Actuation.
It's actuating, correct, yeah.
Actuation, celebration.
So now we will try this with the car running. So then this next part of our EGR / variable valve timing lab, we will be actuating our solenoid while the engine is running and witnessing the result. So we will be grounding out, or be giving power to the solenoid, and it kills it. Wicked.
Welcome to our lab for our 1999 Acura TL. Today we'll be talking about PCVs, PCV valve, and basic operation and function of the PCV. PCV stands for positive crankcase of ventilation. And what happens is the engine is not fully efficient. Some air, known as blow-by vapor, gets through the piston rings, and it gets stuck into the crankcase and really just everywhere we don't want it. So what we have to do is we have to have the PCV to inevitably get it out of the engine and the crankcase. And we have found the most effective method to do this is we have a fresh air and a blow-by vapor side. So we have fresh air coming in through here, and we have a blow-by vapor that's coming out and coming back into the intake. So what we do is we go back into the intake. PCV can inevitably lead up to 30% of our air for our idle. So if you have a MAF, an airflow system, if you have a bad clogged up PCV, that can lead to a very rough idle. If we have a speed density system, that can lead to a high idle, very high idle. Yeah. Basics of PCV. Right here, I have a PCV valve that we removed from this vehicle. We pulled it out of the backside from over here. It originally sits in here. This is the blow-by, not the fresh air. This one right here, this is the fresh air. Brings in fresh air, cycles it through the engine, and this is what pulls that air out of the engine.
Puts it back in the manifold.
How we control that is we either have an orifice or we have a valve. This operates off engine vacuum and back pressure from the engine. And PCV is only active, or PCV is always active, but yeah. Thinking of EGR for a second, but yeah. This is the valve. We can see valving in there, and if we shake it, we We can do what's called the shake test. If it rattles, that means we have a good PCV valve. So you might not be able to hear that, but hopefully you guys can hear that. But it does in fact rattle. Yeah, PCV.